So let's try a couple more example problems involving vector-valued functions. How about this one? Let's find a vector-valued function that traces the curve that's common to these two shapes described in R3. So if you think about this shape in R3, in the xz plane, I have a circle. There's no y appearing anywhere. So I can imagine a circle being slid in the y-axis. It's a cylinder. This, as we know from our study of lines and planes, is a plane. It's a plane with a normal vector, a vector perpendicular to the plane, 1, 1, 1. So the curve of intersection of a cylinder and a slanted plane will be an ellipse shape object in R3. So let's answer this problem. The way I'm going to do this is by first parameterizing this cylinder in the xz plane. So what I mean by that is I'm going to take x to be cosine t and z to be sine t. As t ranges from 0 to 2 pi, I'm tracing out the circle described here. Then I'm going to use these x and z equations in the equation for the plane and realize that this equation is equivalent to saying 2 minus x minus z is equal to y. So my answer is my vector-valued function where x is cosine t, z is sine t, and y is given by 2 minus cosine t minus sine t and sine t. In a follow-up video to this one, I will graph this in my software Mathematica to show you indeed that it answers the question. But before that, let's do another example. Let's find a vector-valued function which traces a curve on the intersection of, how about let's try y equals x squared. That's an equation I'm thinking about in R3. And x squared plus y squared plus z squared equals 4. Now, this in R3 is the following. So let me try to sketch in R3 what this might look like. So here's the x, y, and z axes. In the xy axis, I have a parabola. So the parabola comes, like this in the xy plane. Z could be anything. So at any height z, I get a picture of this parabola, meaning the shape is something like shown. I'll also plot this in the follow-up video so we can have a better image than my drawing here. This, however, you should recognize. This is a sphere of radius 2 centered at 0, 0, 0. So I'm not going to attempt to draw a sphere of radius 2, but I would have a sphere here. And I'm looking for a curve that lies on both the sphere and this other three-dimensional shape. Okay, so here's my answer. Here's what I'm going to do. I'm going to take x to be t. So I'm just going to let x equals t. So x would be t. If x is t, then y is t squared. And if x is t and y is t squared, then I can use this and find z. So I think I could subtract x squared and y squared from both sides, and I get 4 minus x squared minus y squared, which would be t to the fourth, and then take a square root. If I put a negative sign in front here, it would also give me a vector valued function on the curve of intersection, but here's one good answer. Okay, see us in the next video where I show you what these two examples look like with the software. All right, I'll see you there.